Alright, what's going on, you guys? Another LeetCode video today. This one's called Number of Islands. So we're given an n by n 2D binary grid, which represents where ones represent land and zeros represent water. And they want us to just return the number of island. So an island is basically surrounded by water and is formed by connecting adjacent lands horizontally or vertically. And then we can assume that all four edges of the grid are surrounded with water. So let's just go ahead and manually count the number of islands in these grids, just so we're sure what they mean by the problem statement. So we can see here, there's a bunch of ones, and all of these ones are going to be connected to a big island with vertical and horizontal adjacency, right? So there's only one island here, and it's pretty straightforward. So you would just return a 1. So for this second grid, we can see that there's no diagonal adjacency. Like, that doesn't count because this one is diagonally adjacent to this one, but those would be separate islands, right? Because only horizontally and vertically adjacent ones count as an island. So these 4 ones in the top left would be an island. This one here would be an island, and then these 2 ones in the bottom right would also be an island. So it's 3 islands. So let's go ahead and whiteboard this problem. So basically, the way we're going to do this is with a depth first search and a flood fill algorithm. So we're going to use flood fill to basically mark all of the ones as visited eventually. So what we're going to do is we're going to iterate, with a 2D or nested loop just over this grid, and we're going to see, okay, is this cell a 1? So no, it's not. So we're just going to skip over it. And let me get this red out. So no, it's not. So we're going to skip over it. So like I said, we're going to iterate over each cell. So we'll go to the next one. We'll see, okay, this is a 1. So we need to start our flood fill, our depth first search. And we basically need to mark. So if we're currently on this cell, we're going to need to do a depth first search. So I'll just circle it. And we're going to need to mark this visited cell as true. We're going to have another 2D grid of Booleans that we'll call visited to just mark all the cells, or all the cells we've already looked at, as visited, because we only want to visit each cell once, right, to count islands a single time. So we're going to do a depth first search. So we'd go down, we'd probably try to search down again, but we would not end up going this way because there's no 1 here. We're only doing our flood fill basically on cells that have the 1. So we'd mark that 1 as visited. We'd eventually go over here and we'd mark this as visited too. And then we'd basically be done with our depth first search. So we would now be at this cell, right? Because that's where we were in the loop. And now we have all these marked as visited. So when we go down to this row, we're not going to count these again. Our num islands right now is going to be 1, by the way. We're going to increment that whenever we encounter a 1 on the grid and it hasn't been visited. So we're going to be at this one now next, and we're going to see it hasn't been visited. So we're going to increment islands again. So number of islands is now going to be 2. We're going to do our depth first search while marking all of these as visited. So our flood fill. So all of these are going to be visited. They're going to change to true. Okay. And now we're going to go down to the second row. We're going to see, okay, there's a 1 here, but it's already been visited. So we don't want to recount the same island. So we're going to skip over this one also. This whole row, this 1 here was also visited already, so we skip it. Next row, that 1 already visited. Okay, and we see a 1 now that has not been visited. So we're going to increment our number of islands, set this to true, and that's the only 1. So our depth first search ends. We go to this 0, this 1. This 1 has also not been visited. So we got to increment our islands, number of islands again. Okay, and that's pretty much it for the algorithm. We can see every one has been visited, and we can see that there are 4 islands on this grid, right? So, and those are the 4 islands, just to make it a little bit clearer. So let's go ahead and get into the code. Actually, before we do that, let's talk about the time and space complexity. So the time complexity for this problem is going to be big O of m by n, right? Where those are just the dimensions of the grid, because we're going to have to visit each cell on the grid once. We're also potentially doing a depth first search, but notice, we're marking the ones as visited as we see them. So we're really only going to visit each cell maybe 2 times, most, but not more than like a linear constant there. It's going to be big O of m times n, just linear with those, the grid size, right? So that's the time, and then the space is just going to be big O m times n also, because we've got to have m times n cells in this visited grid. So we have another data structure here for this grid. We also have, now that I think about it, in our depth first search, we're doing a depth first search here for a flood fill. So we're going to have some constant there. You could potentially have an island that is the entire size of the grid, in which case your call stack would have to be you have a plus sign here, and your call stack could literally also be m times n, right? So, but that would be like the absolute worst case. On average, you'd probably this is probably going to be way smaller, but this is for the call stack here. So, and there is going to be some space for the recursive call stack, so kind of important to mention that. So m times n plus m times n, that's just going to be 2 m times n, right? So 2 is a constant, so I think technically we can just say this is still big O of m times n, right? Because we can ignore constants in big O notation. So, but it is important still to, consider the space of the recursive call stack. So anyways, yeah, let's get into the code here. So we're going to need a 2D Boolean vector for the, to mark which cells we visited. So we'll just call that visited. Let's actually initialize it too. So it's going to have grid.size, number of rows, and it's also going to have each one of those rows we actually have to initialize. So each row is going to be a vector of booleans of size, however many column elements there are. So grid 0.size, and then we want those all to be false to begin with. So we're going to pass in false there to this vector constructor. And hopefully I did this. The syntax is a little, it's a lot for that and doing it in one line, but yeah, I think that's correct. Okay, so let's, we need to do a 2D loop now. So I'll just use C style. So we're going to say, I is less than grid.size, so the number of rows on the outside of our loop, and then on the inside, we're just going to use j. So j is less than the number of columns, so grid 0.size. Okay, and let's see, a little bit of some typos here, so fixing those. Okay, so that looks good. All right, so we're gonna have to basically check, before we call our depth first search, because we don't want a depth first search if we've already visited this cell, right? So we need to make sure we haven't already visited. So if not visited I j, So if not visited ij, also, before we need to see, right, if this cell's a 1 to begin with. I mean, if we're on water, we also don't want to search, right? So if grid, and the grid is characters, so we have to do an equality with the 0 character. They're not integers, so don't get confused there. So if grid ij is a 1, right? So if it's land and it hasn't been visited, then we're gonna do our depth first search, right? So that's just gonna be, we'll just say, I'll call the algorithm flood fill, right? Or call the function flood fill because it's really what it is. So we want to say flood fill. We also want to say num islands plus plus, which we didn't create that variable yet, but we're just going to be incrementing the number of islands, right, as we go. So that'll be external to the flood fill function. Okay, so let's write our flood fill function. Basically, all this is doing is just marking every single adjacent, horizontally or vertically adjacent 1 as visited. That way we're not recounting or counting islands more than once, right? So that's the nature of the flood fill algorithm. So, but let's implement it. So it'll be void, so it's not gonna have a return value. We call it flood fill. So it's gonna take some parameters. It's kind of like a depth first search. I mean, it really is a depth first search. So we're gonna have an I and j, so just the grid coordinates. We also want the grid. We want the grid by reference. We also want the this visited grid of booleans, right? So we'll call this visited. And then we want the number of islands too, right? Just by reference. Or actually, no, we don't need that because we're incrementing that externally to this function, right? So yeah, this is good here. Should be. So first thing we want to check, right, is just we want to make sure that this cell is a 1 and that it hasn't already been visited. So if the grid at ij at this point of our flood fill is equal to water, or or it's been visited, then we just want to return, right? We don't want to keep searching. Otherwise, we're going to, if it is a 1, and it hasn't been visited, then we're going to set visited at ij to be true, right? So just to indicate that we have now visited this cell. Okay, now we just want to search its neighbors to mark all of them as visited too, if they're land. So we need to make sure we're staying in bounds. So we're going to increment I. We're also going to, but if we increment I by 1, let's just go ahead and take care of this condition. So if we're incrementing I by 1, we want it to be less than the size of the grid's columns, right? We don't want I to go out of bounds, basically in the positive direction. And then we just call flood fill recursively. And then we've got to do that for all 4 directions, right? Horizontally and vertically. So j plus 1 is the most similar because it's just in the positive direction, but it's for the columns. We also have to do -1, and we can just say greater than or equal to 0 to remain in bounds in the negative direction. And then same exact thing for j, greater than or equal to 0. Okay, and then it's just a matter of passing in the parameters, right? So I plus 1, j, grid, visited. And it's pretty much going to be almost the same for these, but obviously the way we're incrementing or decrementing the those ij coordinates is going to change for each direction. So for this, we have j plus 1, and then finally j minus 1. Okay, so that's about it for the code. So let's go ahead and run this. And I forgot to seed this, so this is actually not going to work. Let's, so ij, let's see, grid, and visited. Okay, so that should be it. Let's go ahead and run this now. And I didn't submit it, so a non-void function does not return a value because we never returned the number of islands. So num islands. Okay, that should be it. So let's submit and see how we did. So hopefully this video helps you understand number of islands better on LeetCode. If it does, leave a like and subscribe. I'll see you guys in the next video. Peace.